So if we first kind of break down what these are, kind of to refresh our memory, when we find a mean, it will generally be from sample data. So we call it a sample mean. And this just describes the average of the data set. And most likely we're familiar with how to find an average. We look at taking the total values, add all the values together, and we divide by the number of values we added together. There is some notation that we want to be familiar with. So a mean, a sample mean, is described by x bar. And so x bar is a notation for sample mean. Anytime we see this, it represents a sample average. And that is the sum of each x value, or sum of each value in the data set divided by the total. That will be our sample mean. And a mid-range, which is more likely new for us. So the median, we know that is the value that's in the middle of the data set. It divides the data set into two equal portions. So anything below the median is in the bottom 50%, and anything above the median is in the upper 50%. And of course, the mode is the value that occurs the most, it's most frequent. For our mid-range, the mid-range is best described by taking, it's the midpoint. So it's the value in the middle of the two extreme numbers, the very largest number and the very smallest number. So to find the mid-range, we look at whatever the highest value is plus the lowest value, and we divide that by 2. And so these four values help us describe the data set as far as what the center might be. Now, in the previous unit, in Unit 1, we did talk about histograms, and so that information has not left us. So I wanted to bring back this image from before and kind of talk about how it applies to this unit and this chapter specifically when we look at measures of center. So for any bell-shaped distribution, any distribution that's approximately symmetric, we look at three things being true, and those three things are that the mean and the median and the mode are approximately the same value. So any distribution that takes on this shape that's approximately symmetric or roughly bell-shaped, we look at the mean, median, and mode being roughly the same value, and they should be located near the center of the data set. For a distribution that's negatively skewed, we look at the fact that the mean is actually a lower value than the median, always. And the mode, typically, if we don't have access to the data, if all we have is the histogram, we generally look at the mode being in whatever the highest bar is. So in this case, the mode will fluctuate depending on where the highest bar is for the frequency. But in any distribution that's negatively or left skewed, then the average is going to be a lower value than the median. So in this case, for the example of this distribution, I'm estimating the average to be around 20, and the median possibly could be around 22 or 21. And so we'll look at an example of ungrouped data where we find the information, and then we'll create a distribution to kind of see that property. For positively skewed data, again, the mode will occur in the highest location of the graph for that distribution, and the mean will be a greater value. So in this case, our mean that I'm estimating for this distribution is going to be, let's say, roughly 9, whereas the median is going to be lower than that. If we look at the scale here on the x-axis, if I estimate the median for this particular distribution, just for the illustration purposes, because every single positively or right skewed distribution is going to have this same property, that the mean is always greater than the median. And so we're going to see that in the distribution that we're going to look at here in a little bit for an example. So for our first example, we have some celebrities who are non-living and their current top earnings, so based on royalties and estates, and we want to find the mean, median, mode, and mid-range for the data set. And this is univariate data because it only represents one thing, and that is the top earnings for non-living celebrities. And we want to comment on the skewness. So first we look at, well, how can we find and describe the mean Well, the mean is just an average. So to find that average, I look at, well, what is the sum of each of those numbers divided by the total? So if we were to add all these values together, and there's 13 values here, I believe we get 247 when we add them up, divided by 13. 19 would be our mean, but because the values are millions, we want to make sure we retain that same information, so 19 million would be the average. So that would be the average top earnings in royalties or estate earnings for these sample of non-living celebrities. Now for the median, to find the middle value, generally we want to be able to locate the value in the middle. So for most people, depending on the data set, they may use a technique where they go through and they start marking off values from each end until they get to the center. And so that's essentially what I'm illustrating here, that if I mark one value off from each side until I get to the center value, that's going to be my middle. And I know that's the middle value because there should be an equal number of values below it or above it and below it. So in this case, if I say this 10 is in the middle and there's 13 total values, then I would expect one of them is the middle value. So that would remain 12 values to be distributed on an equal number on the left and the right. So in this case, there are 6 above it and 6 below it. So my median would be 10 million. And for my mode, it's whichever value occurs the most. Now, several values repeat. So there's 2 10s in the data set, there's 2 8s in the data set, and there's 3 7s. And we want the one that repeats the most. In this case, it would be the 3 7s. So 7 million would be our mode. For our mid-range, which is like a midpoint, we look at the largest and the smallest value. I take that value, add them together, divide by 2, and that's my midpoint value, which is 28.5 million. So we take this information and we think about, well, how can we comment on the skewness of the distribution? Mainly, we're going to look at the mean and the median for that. So if my mean is $19 million and my median is $10 million, since the mean is a lot higher than the median, then that is going to create a distribution that will be skewed to the right. And I'm actually going to show you how that looks here in a moment. So to illustrate the skewness in this distribution, what I've done is I've taken the data and input the data into Excel. And so this is the data, but I also made a frequency table as well to record how many times the value was observed in the data set. And this is not anything that you have to do because it's not going to ask you in the homework to describe the skewness. I just wanted to talk about it, kind of to carry over that information from Unit 1. But everything had a frequency of 1 except for 10, 8, and 7. 10 had 2 data values, 8 had 2 data values, and 7 had 3 data values. And then we see in this kind of a dot plot here that it's skewed to the left because the data set is higher on the skewed to the right. I apologize. The data set is higher on the left side, and as we increase in value, it decreases, and so it's being the higher values are stretching out the data set on the right side. So this is the typical view of a data set that is skewed to the right. Now we can also make a histogram too, but I want it to more so show a dot plot. Well, I guess I can make a histogram so you can kind of see that. So it won't really be too much to make a histogram in Excel. There were 2 10s and 2 8s and 2 7s, or 3 7s. So if I want to make a histogram, I select the data, insert, click on histograms. And so I really want to change the bin size. So let's say for our data, I'm going to change the bin, which are the class limits or the class boundaries. So let's say I want to have 5 of them. So if I have 5 of them, this is the distribution it makes. and I can just increase it to kind of change the distribution. But as I increase it, probably 5 is a good number, probably even say 6. We can see definitely that this is it's very skewed to the right, but we can see the skewed shape in the distribution. So anytime that we have a situation where the mean is greater than the median, it's going to create that skewness in the distribution. Now, the other way in which we can describe the mean of group data, so this should look familiar to you. In Unit 1 in Chapter 2, we looked at a frequency, a grouped frequency distribution, and so now we can actually find the mean of that. And unlike a traditional mean, it still is the average. However, in this particular table, I don't know any of the numbers. I only know that there's 11 values between 0.5 and 3.5. And there's 12 values between 3.5 and 6.5. I don't know what those 11 values are. So for us to find the average, we have to figure out a way or devise a way to estimate that what these 11 numbers could be and what these 12 numbers could be. And so in doing that, we look at our mean is going to be described for this type of distribution. It's still X bar because it's a sample mean. So a random sample of bonuses in millions of dollars paid by large companies to their executives is shown. So these boundaries represent bonuses in millions of dollars, and 11 people received a bonus from $500,000 to $3.5 million, all the way up to one person getting the bonus of $12.5 million to $15 million. So for me to find the average of the distribution, I look at the sum of the frequency, so these numbers, multiplied by the midpoint. So the midpoint is something that we are familiar with as well from the previous unit. Right? The midpoint was described as the lower bound plus the upper bound divided by 2. So that's what we looked at. That is what we looked at the midpoint being. So we first want to find the midpoint, and the midpoint for us in this class is going to represent the typical value for those 11 values in that interval. Now, needless to say, we don't have the actual data, so we don't know, but we're using that to represent like the typical value. And subsequently, the midpoint would also be like an average of those two numbers, because we're adding them together and we're dividing by 2. So that for us, that's a typical value. So to find the midpoints, and again, this comes from section 2.1 and 2.2, I would add together the upper bound and the lower bound, divide by 2, and that's my midpoint. In this case, that midpoint is 2. So the typical value for these 11 numbers is estimated to be 2. And we do that for all of them until we get to the very end. And I'm just, quickly, I noticed that over here, each time they're adding by 3. So if I just added 3 to 2, I get 5. If I added 3 to 8, add 3 to 5, I get 8. Add 3 to 8, I get 11. And 3 to 11, I get 14. So we can do that as well. Now, this last column is what is going to help us find the average. So the average is the sum of this column, the frequency times the midpoint. So if we actually knew these 11 numbers, we would just add those 11 numbers together, and that would be the total bonus for the total bonus paid to the 11 people in this class boundary. But since we don't know the value of each 11, instead we're going to use the midpoint to represent the typical bonus that each person received, each of the 11 people received. So the total bonus that we're estimating to be paid out for this interval will be $22. It's it represents the frequency of 11. So frequency of 11 times the midpoint of 2, and that gives us $22. Same thing with the next one. We look at taking a frequency of 12. So there's 12 individuals in this interval that received a bonus from 3.5 million to 6.5 million. And a midpoint of 5 just tells us that the typical bonus was around $5 million. So those 12 people, if we say received each $5 million, then that's 60 million total for that interval. And I'm just rewriting it so that the values line up. So 11 is the frequency, x of m is the midpoint, so 11 times 2 is 22. And then we complete that process for the rest of the information in the table, and we get values that represent the sum of the bonus for each class boundary. And then to find the mean of the entire distribution, the sample mean, I take the sum of this column, so 22 plus 60 plus 32 plus 22 plus 14. I want to add that together. So we add that together, we get 150. And then n represents the total. In this case, the total sample. The total sample would be, if I were to add all these together, how many people are represented in this distribution to have received a bonus, and it's 30 people total. So the sum of the frequency times the midpoint divided by n, 150 divided by 30, that would be 5, would be our average, $5 million. So the average bonus that was paid out was $5 million. Now the other thing it wants us to find is a modal class for the distribution. So in this case, just like the previous problem, we could find the mode for the previous problem because we could actually look to see which number was repeated. For this one, we don't have that luxury. I don't know the values, the 11 different numbers in this interval. I don't know the 11 different numbers in this class boundary. I don't know the 4. For all we know, these 4 could be the same number, and this is 11 different numbers, and this is 12 different numbers, and really the mode is here. But because we have a grouped frequency distribution, we consider a modal class represents the class, so one of these, that has the highest occurrence of values. So that would be 12 would be our modal class. And then we can even describe the shape of this distribution. If I make kind of a quick sketch of a histogram here, we can kind of describe the shape of the distribution. We really don't need to make a histogram, but I still like to make one just for a visual, for those of you who are very visual. And so based on the frequency and the class boundaries, this is the histogram, and we can see it's skewed right. The majority of the data is clustered on the lower end of the values, and then as it increases in value, it starts to taper down. So the mean, in this case, would be far greater than the median.